In this problem, we are going to look at how we solve a linear equation by clearing fractions first. You can see we have 4 steps to follow. The first step is to multiply both sides of the equation by the lowest common denominator that will clear the fractions. In my equation, I have 2 fractions. One has a denominator of 5, the other fraction has a denominator of 3. This means I will use the LCD of 15 to multiply both sides of the equation. The LCD of 15 will clear the equation of fractions. So I'm going to multiply both sides of the equation by 15, and I'm going to write it as 15 over 1 because I am multiplying by another fraction. Making sure to do the same thing to the other side of the equal sign. Now I'm going to distribute 15 to everything in the equation. When I distribute to x plus 2 over 5, the 15 gets multiplied by the binomial in the numerator, and in the denominator I just have 1 times 5. Then I multiply 15 times 9. On the other side of the equal sign, I'm going to distribute 15 to the binomial in the numerator. So 15 will get multiplied by x minus 3, and in the denominator, 3 times 1. Now I'm going to simplify. I notice 15 over 5 is the same as 3 over 1. So really, I'm just going to be distributing 3 to the binomial x plus 2. Then I'm going to add the product of 15 times 9, which is 135. And then on the right side, I'm going to simplify again. 15 over 3 simplifies to 5 over 1. So I'm really just distributing 5 to the binomial x minus 3. Notice, no more fractions. That's the whole reason why we chose the LCD 15 to multiply by both sides of the equation. Now I just have to do a little bit more distributing to solve the linear equation. I will get 3x plus 6 plus 135 equals 5x minus 15. Then I'm going to combine like terms to get 3x plus 141 equals 5x minus 15. Next, I'll subtract 3x from both sides, and I'll get 141 equals 2x minus 15. Add 15 to both sides to get 2x equals 156. And finally, we divide by 2 for our solution of x equals 78. Of course, you can take 78 and plug it back into the original equation everywhere you see x, and you will see that the equation balances.